everyone, and welcome to Data Science at UC Berkeley. So I wanted to start with this talk with a quick photo. And I'm sure you've seen this photo around several times today, but we wanted to show you what happened at UC Berkeley yesterday. This was in 150 Wheeler, the biggest lecture room on campus. And as you can see, our first lecture of Data 8 is packed. There are people sitting on the ground, and this exciting movement at Berkeley is something that we wanted to bring to you today. So how did it all start? I actually wanted to ask you guys a question. How many of you have read the book Little Woman? Raise your hands. A fair number. I'm impressed. And for those of you who haven't, this is how the first lecture of Data 8 went. I was actually a freshman in this class 2 years ago when Professor De Niro took the stage, and he started talking. He asked that same question of us, and a fair portion of us had read it, a fair had not. And he went through how a computer could read the book, Little Woman. So let's take a quick look. What he did was take the Project Gutenberg version of Little Woman, the text, and then split it by chapter. And once they were split by chapter, he did something very interesting. As you can see in that minute line of code that you see to create that table, he took the characters, each of the 5 main characters of Little Woman, and took the character counts for each of them in every chapter. A very simple data science operation. The main point here is not the code, it's just the image. So let's take a quick look. So for those of you who haven't read the book, can you guys tell who the main character is just by this graph?
Joe.
Yes, Joe, exactly. So we've never read the book, but we can tell that Joe is the main character in this book because she's mentioned the most. So the book, if you guys have heard of it before, has followed 4 of the March sisters, Jo, Meg, Amy, and Beth, through the 1860s in their daily life. But there's a 5th character on there, Laurie. And Laurie is the boy next door. Laurie actually ends up marrying one of these girls. From this image, can you tell who he marries? Amy, exactly. And as you can see, they're kind of rising in lockstep towards the end. And you got all of that without reading the book Little Woman at all.
Did Meg die?
What? Ooh.
Excuse me.
So, without giving away the ending, you can tell a lot from how Data 8 looks at the book Little Woman. And I can tell you that sitting there in that lecture hall, this was probably one of the most inspiring moments for me. So what does the program look like in numbers? There are 1,500 undergraduates enrolled in UC Berkeley's current fall 2017 offerings. We have a 50-50 gender representation, which is highly unlikely for classes in STEM, especially even at top schools like UC Berkeley. We have 150-plus size core staff of students that are helping manage Data 8, as well as some professors. And we have 21 unique data science connector course offerings. So what exactly is a connector course? It's a 2-unit data science application seminar, like these mentioned on the slide here. And they range from topics like data science for cognitive neuroscience and data science for smart cities. And they're small courses with a professor that students can take alongside Data 8 to learn about that domain application. We also have 3 extender courses, Data 100, Stat 140, Stat 28, and 15 modules, which are units of data science and already taken courses at Berkeley. So as you can see, data science is becoming a huge movement. But who are the people taking this class?
Do you have online, or is it just for people in Berkeley?
So actually, all the materials are online. The textbook is at inferentialthinking.com. And we're looking towards making this a MOOC, hopefully in the future, in maybe a year or so. So keep an eye out for that. But there is a major and a minor program coming up as well. Now, who's taking Data 8? We see a huge host of students. And this class has actually been the most rapid growing class that Berkeley's ever seen in the history of all time. So we see 2 years of Data 8 enrollment figures. And for fall 2017, the enrollment hasn't finished. But it's projected to be, again, around 1,500 students taking the data science offerings. People come from, what's the question? The 8 is actually because of some kind of, there was a lot of classes called 1, and I know they had a reason for 8, but I think they've kind of kept along the theme. The connector courses are all 88s. So why not is probably the better reason. So in terms of the years of students who are taking it, they're not only freshmen. There are freshmen, sophomore, juniors, and seniors, a very diverse class in terms of year, and a very diverse class in terms of experience level for their programming abilities as well. We have 60+ majors represented in this class, and perhaps the most important thing is that this class has no prerequisites. You can be a sociology major in your senior year and have never touched computer science or advanced math at all, and start by taking this course and go all the way from not knowing how to write a line of code to being able to do classification at the end of the course. So who are we, and why are we qualified to speak to you today? My name is Vinitra Swamy. I am the head of the Data Science Education Program Jupyter Infrastructure team, and also the head GSI of Data 8 for the coming semester, as well as in the years past. I just finished my bachelor's in computer science at UC Berkeley, and I'm a master's student this coming year. But if you're kind of confused about the timeline, because I did say I was a freshman 2 years ago, I graduated a little early.
Hi, everyone. My name is Gunjan Baid. I am also going to be a master's student this fall at Berkeley in computer science. I graduated last year, and I studied computer science and biology. And I got involved in the data science program initially as a TA for one of the courses. And now I'm helping out as a technical lead for the connector courses, which you heard Vinitra just mention. So as a technical lead, I kind of do a variety of things. I help maintain the JupyterHub deployment. I interface with the instructors and talk to them about our technology, and I help build and design new tools. So the way that we've structured this talk is Vinitra will tell you about Data 8 and the course in the first half, and then the second half, I'll tell you about the student workflow, so the technology that we've developed and how students are using it in these courses.
Thanks, Gunjan. So with that, let's get started. How do we use Jupyter to teach data science at UC Berkeley? So the start of this all was in June 2014, where the chancellor, the then chancellor of that time, provided this rapid action call for a data science team. And what it says is that we want people to learn about quantitative reasoning, how to effectively understand, process, and interpret information as citizens of the world in the 21st century, a very noble call to action. And that's kind of what started this whole movement, especially around this new emerging field of data science. But with it came some challenges. How do we design a computing course for everybody? Right? You see on that page there were people from all different years, all different skill levels, some of whom knew programming very well and some of whom had not touched code in their life. So the first goal we had was to remove this thing that UV in the back likes to call the command line tax, or what I like to call the setup cost. So when you're initially learning programming, and I'm sure many of you can code in this room, the initial setting up your IDE, installing the libraries, going through terminal, that cost is very intimidating to students who are from different disciplines and have never touched computing before. And we want this course to be as accessible as possible. So that's what we use JupyterHub to address. We also want to make computing relevant for majors that are not CS and stats, which means that those economics majors, we want to find them applications in this course itself that they can relate to. And we want to have course content that appeals to all demographics. We don't want, for example, only NBA information, because then some of the other demographics who don't actually care about basketball might feel a little left out. Or on the other hand, we also don't want just kind of like a shopping data set, because we also want them to be real world issues that people can take and think critically about the world around them. So our solution was this kind of infrastructure that we developed, which was done in Jupyter. We used GitHub to help instructors pull files. We used Docker and Kubernetes as kind of a backbone. But the result of all of this is that a student can use a Chromebook to set up their data science environment. So what does this course actually look like for the students? There's several mandatory aspects of any course. One of them is lecture, which happens 3 days a week on Mondays, Wednesdays, and Fridays. And there's a weekly lab, which are 2 hours every week. And these are pretty much done both entirely kind of in Jupyter notebooks with different people explaining them. But I think the key to Data 8 is also the support infrastructure we've developed. We have office hours, not only from professors, but from TAs and from tutors. We have lab assistants helping in labs. We have designated tutoring sessions for anyone who's falling behind in the course. We have review lectures and extra topic lectures, which are special advanced lectures that me and some of the other GSIs often teach. And we also have guerrilla sections, which are group working boot camps for certain topics in the course that might be a little challenging, like bootstrap sampling or regression. And we're also implementing this new thing called homework parties, which sounds ideal for undergraduates, but it's mostly like you sit down and you hang out with all of your friends, we bring snacks, and you guys can work through the homework together. And the backbone of this course from a technical standpoint is also the data science library. As Jorge Luis Borges said, I've always imagined paradise will be a kind of library. He was an Argentinian poet. I also agree with that statement. This is perhaps not the library he was thinking of. But what it does is that it includes this table format in a very interesting way. It's based very heavily on pandas, but it takes away the extra arguments that you need that would make the teaching of certain pandas functions complicated. There's also a huge emphasis on this class in data visualization. So as you can see in the corner, you see some regression lines, some overlapped histograms, also some interactive maps. But what we also do is use OkPy widgets to create interactive visualizations. So as you can see here, people are looking in this project, which is project 1, on global population data. On 1, the children per woman, which is the fertility rate, and comparing that against the infant mortality rate for various countries over many years. And by using interactive OkPy widgets, students are actually able to see that transition for themselves. We also go all the way to a very somewhat basic example of machine learning in this class, in the sense that we teach classification and k-nearest neighbors. So in this project, we take lyrics, song lyrics that are relatable to everyone, and try to classify them into country and hip hop. So we start by cleaning the data, stemming all of the words, and then splitting the data sets into training and test. And from there, they're able to go into feature engineering and choose which word vectors they think are most appropriate. They're also able to evaluate their classifier and look at evaluation metrics from that aspect. And beyond that, we encourage them, actually, to beat our own staff classifier. And 54 teams of students actually took us up on it. So they actually went into a Kaggle competition that we set up last semester, and they did incredible things. They took that initial spark of data science, used whatever libraries and tools they could find, and some of our first-year freshmen even found TensorFlow and were able to get their accuracy up to around 98%, which was remarkable. So it's basically giving them the opportunity to take the knowledge that they're gaining in class and then go forth and explore on their own. Other problems that we take a look at are, for example, cancer screening. What does a positive test result actually mean? And from there, teaching conditional probability. If you have a positive test result, how likely are you actually to get cancer? For World War II, we looked at the example of the British Royal Air Force and how they predict the number of German enemy warplanes. So when they see the planes circling above, they each have numbers on them. An easy thing to do would be to look at the max of the number of airplanes they see above and say, OK, we saw a number 52. They must have at least 52 warplanes. But we also know that would always be an underestimate of the number of warplanes that would actually exist. So they come up with their own test statistics by taking the mean, multiplying that by 2, and create a more normal distribution of what the number of enemy German warplanes actually look like. Because that's one thing you don't want to underestimate. And in that, we also go forth and teach bootstrap sampling, confidence intervals, and some fairly complex statistical concepts. We also, one of my personal favorites, is estimating the age of the universe by looking at the ages of nearby stars and their explosions. And with that, we teach regression. So how does this look like for the students? They get to look at some really interesting data sets, some really cool problems through guided explorations and explorations of their own. But all they see is the tip of the iceberg. So they see Jupyter, they have their own file server, and they also see this notebook format where they go through the exercises. But under the tip of the water is what me, Gunjan, and I would like to give a shout out to UV and Peter, who help us very much in the infrastructure team, to manage Kubernetes, Docker, OkPy, which is an auto-grading system that we've developed at Berkeley, and JupyterHub, which is kind of the cloud-based infrastructure. And with this class, especially of this size, we face a lot of challenges. Some interesting problems that we've run into is, in terms of technical skill, how do we provide real-time support to students? Every minute that their server is down or something is broken, that's a minute that they don't have to work on their project for a deadline. And we know that because these are undergraduates, they're often working at 2 a.m. the night before something is due, and if something breaks, that's on us to fix it. Beyond Data 8, we want to export their work for future use, and especially because this might be, for some of them, their only computing class, we want them to have that arsenal of tools that are not limited just to the hub infrastructure. From a pedagogical aspect, there's certain other challenges that are interesting. We want to balance the computer science stats and the domain applications in a way that's equitable for all of the interesting fields that make up data science. And we also want to make sure that the class structure favors skills that they can really use in the real world, but also prepares them for the exams that we are giving. So the balance between in lab using a worksheet and then the second half using a Jupyter lab. And of course, the tests are in pencil and paper because that's the way we've always done tests. But we want them to take these skills also to the real world and be able to use Python beyond that. So how do we manage our 1,000+ active users? We use Piazza, which is a discussion forum for students to post and ask questions and instructors to answer them. And students can answer other questions of other students as well. And then we also use Slack, which is a messaging app. And in that, we've developed an autoscaler bot channel to tell us real-time statistics of what's happening with JupyterHub. And this is mostly from the staff side to manage internal communication. And the surrounding ecosystem is something Gunjan is going to be talking about very shortly. And for that, we're using GitHub, OkPy, and a variety of different needs from each of the connector courses, which with it provides its own challenges. So with that, I will give it to Gunjan so she can talk about the student workflow.
All right, thank you, Vinitra. So you heard a little bit about what the Foundations course, which is Data 8, is like. I'm now going to talk to you about the student workflow. So how do students do their work in these classes, and specifically, what kind of technology do they use to do their work? So before I actually get to the technology, I have this diagram of what we like to call the data science education stack. That line in the middle represents an abstraction barrier, and everything above that is what's visible to the students, which is kind of what we just discussed, the data science package, the tables abstraction, and notebooks. And then the things below that are the ones that are kind of abstracted away from them. So I'm going to focus on that third layer right there, which is the JupyterHub and the surrounding ecosystem. So students can see these tools. They know they're working on a JupyterHub, but they don't actually know any of the details about the systems. We kind of take care of managing all of these things for them, and it's kind of just like a black box for them. So specifically what's at that level is, as I said, the JupyterHub. That's kind of like the main piece of technology that they use. That's where they do all their work. And then there's two other tools that make up the surrounding ecosystem, which are Interact Links and OkPy, also called OK. So here is how these tools actually fit into the student workflow. The most basic things that students need to do in these classes is get their files, which are notebooks, work on those files, and then submit them. So to get their files, they use a technology called Interact Links, and then they pull those notebooks into their JupyterHubs with those links, and then they do their work in the JupyterHub, and then when they go to submit their files, they use a tool called OK. So before I go into details, I want to give you a little bit more motivation for why we designed this technology and some of the pedagogy behind it. So these images are actually from my very first computer science lab at Berkeley. The whole lab was basically just like installing a bunch of stuff and learning how to use a terminal. And I had a Windows computer at the time, so the whole thing was really stressful and like nothing worked properly. No offense, Windows users, but it was terrible. So that's kind of exactly what we wanted to avoid in this class, which was like the burden of setting up and maintaining a development environment. And especially so because this is a class that's not just for CS majors, it's for students of all backgrounds. As you heard, we have like 60+ majors in the course, and we don't want this to be kind of their first experience in the class. That doesn't go to say that we don't want to teach these things at all. These will be taught in later courses in the program. These are just not things that we want to kind of start off with in the very first week. So student workflow, I'm actually going to go out of order a little bit when I talk about these tools. I'm going to start off with the JupyterHub, since that's kind of like the main piece. So for anyone that's not familiar, JupyterHub is a multi-user server for working with Jupyter notebooks. So similar to how you would run Jupyter locally on your own machine, you can also work with Jupyter notebooks on a JupyterHub where multiple users can be on the same hub. So we've set up this hub for students in our program, and the way it works is they just go to a URL and they just type it in their browser, and they're taken to a login page, and they can then access a JupyterHub and see kind of that standard Jupyter homepage. So the first time a student logs in, they get a personal account created for them, and they have like their own file system on the hub, and it persists throughout the semester. So basically what this means is that instead of seeing all of that installation and setup on day one and like week one, because it takes forever to get through, students are able to actually like interact with real code and see demos and actually do things in class like right on the first day. That demo you saw from Vinitra's portion about the Little Women lecture, that's the first lecture. Like literally, right as class starts, students are able to log on and interact with that code and see all of that on their own machine. So this is a really powerful tool to have, and it makes everything a lot simpler for the students. So I'll talk a little bit more about some of the benefits of having a JupyterHub. I mentioned, the no installation and setup. That's pretty obvious. It's really nice not to have to deal with that in the courses. It doesn't mean that all of that work kind of goes away. It means that it's shifted from a group of users that's like completely new to these tools and probably doesn't have any idea, probably does not know them very well, to a set of experts that's able to manage it much better and knows the ins and outs of some of these tools. And some of those people are sitting here in this room, so I want to thank them for all of the work they've done in managing our JupyterHub. Another benefit of having this JupyterHub is that it's really easy to troubleshoot. So having been a TA, I was always really nervous when I had to troubleshoot other people's Windows computers because I had a Mac computer at the time. So having kind of a common system that everybody works on is really nice because it takes a lot of burden off the instructors and the staff that are helping students with troubleshooting their issues. And then another point that you may or may not have thought about is JupyterHub kind of gives everyone equal resources. So they have the same compute power, they have the same system that they're working on, they have the same memory, everything is pretty much the same. So what this means is you can have a Chromebook, you don't even need a laptop, you can go to the library and use a library computer, and you're not at any sort of a disadvantage in this class. So this is really nice to kind of make sure that everyone is on a level playing field, and like certain groups of people aren't at a disadvantage based on what kind of computer they have and things like that. So yeah, that's kind of a central piece, the JupyterHub. That's where students spend most of their time. But the step that comes before that, before they can work on these notebooks, they have to actually get the notebooks into the JupyterHub. So the way that they do that in some of these courses is through what are called interact links. So here is what an interact link looks like. And how these work is students basically just click on these links, and in the background, files are pulled into their JupyterHub account. What's going on under the covers is that these run a series of git commands to pull all the necessary files into the student's account. But what it looks like for the students is just like some magic happening, and then the files show up in their account, and they can just start working. They don't see any of the details of like how it's implemented. And this is really nice because we don't have to teach them how to use Git. We don't have to teach them how to use the command line. They can just get started with these right away. So these are enabled through a Jupyter extension that we've developed called Git Autosync. And basically, the extension allows you to create links in this format. And I've highlighted the different portions with different colors so you can kind of see how they work. So this link, for example, would pull Lab 1 from the GH Pages branch in the Social Networks Connector repository in the Data 8 GitHub account into the red URL, which is the JupyterHub. And it would pull the files into the account of the person clicking the link. So what this looks like for a student is basically they go to some course website, they click a link for the assignment they want to work on, and they're just taken to the files in their account that they need for that assignment. So here's a demo of what that looks like. Oh, didn't start off at the right point. So I'm going to wait for it to finish up. OK, here we go. So I'm going to click on the assignment link. And then I'm redirected to the JupyterHub, and there's some files in there, and I can open up the notebook. And there you have it. That's all it takes to obtain a notebook into your personal account. No need to use a command line, no need to like zip up files and upload them to JupyterHub. It's very simple with just one click. So the inspiration for these links actually came from a vision that one of the instructors in the program had, which was to create this online textbook that students could interact with and have a very hands-on feel with, not just some like static page that they're reading and not really absorbing anything from. So that vision is what became the Data 8 online textbook, and I'll show you a demo of it in a bit. There's sets of code in the notebook, and there's a bunch of interact links throughout as well. So anytime you see code, you can click on this blue button that will bring all of that code into your own environment, and you can interact with it right away. So here's the textbook. And that's the interact button. And when I click that, it'll pull all that code from the page into my own personal account. So yeah, this just makes it really easy for students to kind of work with the examples that they see. They can get started on them right away. They don't have to like copy paste the code and make sure they have all the necessary libraries and things like that. All right, and then the final piece of the workflow after students have obtained files, worked on them, and finished working on them is to submit them. So for the submission portion, students use a tool called OkPy. This tool was developed at Berkeley by another student who, at the time, was a TA for one of the undergrad computer science classes. That class is also huge. It has like 2,000 students right now. And so this tool was designed to meet the needs of the class, which was just to have like large-scale auto-grading. Since then, they've added on some really cool features for notebooks. And those include auto-grading for both the notebooks and also a really nice submission system. So what I'll show you in a moment is how students use this tool to submit their assignments. So basically what that consists of is they have a cell at the very bottom of the notebook. So after they've worked through the whole notebook, they get to the bottom and they see a submission cell, and they just have to run that cell, and then the notebook gets submitted. That's literally all you have to do. You don't have to download it and go to some other portal. They just run a cell, which they're already doing in the notebooks, and that's the entire process. So here is what that looks like. So I just ran a cell, and as soon as that cell finishes running, the notebook is submitted. And what you see output there is a URL, and that URL takes you to the OK online site. So students can verify that their submissions went through by clicking that URL and viewing their submission in the interface. And then before I talk about challenges, actually, a little bit more on OK. The auto-grading features that I mentioned are also really nice. I didn't include a demo, but if you're interested in learning more, you can come talk to me after. They're pretty similar to how NBGrader works, but because our JupyterHub deployment doesn't have a shared file system, we chose to use OK for the auto-grading purposes. And another nice thing about OK is that it's kind of end-to-end. So students can auto-grade and they can submit their files, and then instructors can view those submissions, grade them, and like give feedback. And there's kind of like a whole workflow around one tool, so you don't have to do a lot of switching back and forth between different things. Yeah, so those are the main components of the basic workflow that students go through in these classes. And as great as these tools are, they come with some challenges. And the first and foremost being that things just break. You saw some of the numbers. These classes are getting really big, and there's a lot of students on the hub. So stuff is breaking constantly, and it's part of what keeps it exciting, but is also a little bit stressful at times. So we're always working to make things better, but this is definitely a challenge. The scale of the classes and the program is definitely a challenge that will continue to last in the near future, I'm sure. And then another challenge is the usability of these tools. So making sure that these tools are things that people, the instructors specifically of the different courses, want to use. So this image is to show you some of the different connector courses that Vinitra talked about. They range in departments and topics, which means that the faculty members also range in various departments, and they have very different skill levels with some of the technology. So designing tools that they all want to use and that they're all comfortable using is definitely a challenge. So some of my work this past semester has been to work with them and to see how we can improve these things and how we can develop other tools that are, along the lines of what they want to see and use in their courses. Okay, so to conclude, we have a couple takeaways that we hope you will carry with you from this talk. First and foremost is kind of the motto of the program, which is like everyone can learn data science. It's not something that's just for computer scientists or statisticians anymore. It's really something that everyone needs to know in this state of the world. And I think that's kind of been a theme throughout the day and some of the keynotes as well, that this is really something that's becoming big and is part of just like basic literacy. And I think that the challenge isn't really getting students excited about the topic. I think that's the easy part. As a student, I can definitely say that these are really exciting problems, and tackling them is something that we want to do. I think the hard part is making sure that some of the courses that we have are designed to support all these different students. So you heard about the work that we've done at Berkeley to make sure the content, which Vinitra talked about, and the technology, which I talked about, are designed so that everyone can take these classes, so that there's no barriers to entry, and that everyone that's interested in these programs can actually continue in them and get the most out of them. So yeah, hopefully that's something that you'll think about if you're instructors in your own classrooms as well. And if this talk has gotten you excited about the possibility of using some of these things, you can check out the first link. It has all the tools that we mentioned in this talk. You'll find a link to each of those pages on that first website. And if you want to see what our JupyterHub deployment is like, you can try out the second link, try.datahub.berkeley.edu. This is very similar to the hub that we've set up for students. And there's also some files in there from the Data 8 course material, so you can see what some of the assignments are like as well. And I believe you'll see a login page on the try.datahub site. You can enter an email, and you can leave the password blank. Oh, question?
So I am totally sold with what you've created. It's pretty awesome.
Uh-huh.
And I'm at the
Great.
link shared, so there's links, but I feel a gap between knowing the links are here and knowing how to do it. What do you recommend as a way of, actually, if I wanted to offer a course at the multiple free school that uses this, what should I do? Or
Yeah.
is it just really a gap that still needs to be filled?
No, so I also put contact information on there. So if you're looking for information on how to get started, I would be happy to talk with you a little bit more about that, and I can come chat after the presentation as well. But hopefully we're trying to bridge that gap. So if you feel like it's there, I'll do my best to kind of address that. So yeah, let's chat more about that.
Oh, and one more point. There was a Zero to JupyterHub guide that was created by some members of the Berkeley Data Science Education Program and various other initiatives. And that was definitely like a really good place to get started on getting your own JupyterHub set up.
Oh, yeah.
To know what position the language actually takes in this whole process, and how students learn that language and are expected to learn it. I think you said that there's like 6 different majors, and some people have no prior experience, so they dive down into these workbooks, and suddenly they have code in front of them. What's that response look like, and how do you guys do that?
So I can address this because it's a somewhat pedagogical concern. We use Python, and we use that also in the other intro class at Berkeley, the CS61A. And the reason we use Python is because, one, the package support is very easy, and the data science library was made for Python. But it's also a very unintimidating programming language in the sense of you don't have to deal with memory abstractions, or you don't have to deal with insane data structures. They start by just learning what a variable is, what a function is, and that's what their first lab goes through. And by learning it in the context of these data science problems, it seems not so intimidating.
Is learning the language one of the goals of the course?
So it is not the primary goal of the course, but it is a goal of the course. So I would say when people leave Data 8, they understand Python very well from a data science perspective, in the sense that they can do all kinds of table manipulations and all kinds of visualizations and are ready in that aspect, but they aren't full-fledged computer scientists in Python yet. And so we recommend them to take 61A, 61B, which is data structures, and those classes beyond Data 8. So the scope of this is to teach computing in the context of their domains, and after that, they have access to computing for itself.
Before we take questions, I want to just officially end the talk and say we have a couple more events related to the data science education program. 2 of them have already happened, but if you want to check out the videos, hopefully those will be up soon. And then there is a Meet the Expert session with me tomorrow. So if you want to come chat more, I will be available for that. And I was told that there's also Jupyter user testing tomorrow. So if you're interested in being a participant in that, that's the link to sign up. And then finally, we just want to say thanks to the many people involved. This is a huge effort. There's so many people that are involved in the program, and it could not be done without them all. So thank you to everyone. And thank you to you all for being here. It's great to have everyone here. Thank you so much.
Gracious enough to answer questions during their talk, so we really only have 2 minutes, so maybe take 1 or 2 questions and then we'll wrap up.
Yeah. Yeah, 1 and then 2.
What about computer science students taking the first computer science course? What do they think of this? Is it too slow for them, or could you separate out for those 1,500 students? I see quite a few have taken computer science already.
So I actually came into the class having also taken that first computer science class, and I also had done my first internship and everything. I was definitely very much a computer scientist, but Data 8 is at its heart a statistics course. So it teaches confidence intervals, bootstrap sampling, probability. Those kind of concepts are not taught in any computer science class, and understanding computing in the context of statistics is something that was never brought up in the curriculum. So in that aspect, they gain a lot, and they also don't have experience. We don't have experience with tables other than SQL and a little bit in the introductory curriculum. We also don't have experience with visualization and various manipulations. So it is worthy, I think.
I also want to add that students that have taken prior computer science and statistics courses are usually recommended to not take the Data 8 course, since it's for more introductory students.
Oh, and one last thing. Those people who end up taking the course anyway, they get to do an extra project, which is a complete data science exploration of their own from start to finish, and they have a set of requirements that they have to complete, but they find their own data set, they do their entire project, and they also present it at a research fair.
Yeah.
Well, I think that was awesome. Absolutely fantastic.
Thank you.
So one of the things you mentioned, at least there's a view of it, is that it takes a lot of human resources in order to implement this. There's a lot of people that have to be on support staff from an infrastructure perspective. And that's kind of hard to sell to a university curriculum coordinator. Obviously, Berkeley is really sold into this. I'm curious, do you guys have a gut feel for how many hours you spend just on the infrastructure side leading up to the first class? I'm assuming it's more automated at this point, but what was the FTE cut? I can answer that because I spent most of the time. Yeah.
Thank you, Yuvi, for stepping in. Actually, we need to go ahead and close out. Thank you, Vinitra. Thank you, Gunjan. I appreciate it. The reception is in the sponsor pavilion.